Ever feel like your code has a mind of its own? You tell it to do one thing and it just does something completely different, or maybe nothing at all. Well, today we're going to put on our detective hats and investigate some common Python mysteries. We're going to learn how to crack the case when your code goes wrong. I mean, we've all been there, right? You've written what looks like perfectly good code. You hit run, you're expecting something awesome to happen, and then crickets. Nothing. Or maybe even worse, something totally weird happens. It's honestly one of the most common and, yeah, frustrating parts of learning to code. Okay, so let's look at our first case file. We've got this simple function here called onMousePress, and the goal is super straightforward. Every single time we click the mouse, a new circle should pop up right in the center of the canvas. Sounds easy enough, doesn't it? But then we run it. You click once, a circle appears. Perfect. You click again and, nothing seems to happen. You click a third time, a fourth, and you're still just staring at that one lonely circle. Is our code broken? Is the computer just ignoring us? This, my friends, is our first mystery. Every good detective needs a toolkit, and our very first tool is what I like to call the coder's magnifying glass, this simple but incredibly powerful print statement. This is how we're going to find our first clue and see what's really going on behind the scenes. So to investigate, we're just going to add one single line of code. On the left, you see our original mystery, and on the right, we've slipped in a print statement right inside the function. Think of this like a little informant that's going to tell us every single time the function gets called, and it'll even report back the mouse's coordinates. And there it is, the evidence. With every single click, a new message pops up in our console. This confirms it. Our function is running each and every time we click. So the problem isn't that the code is broken, it's that we're drawing a new circle directly on top of the old one, over and over again. Case closed. Excellent work on that first case, detective. But, sometimes a magnifying glass just isn't enough. For our next investigation, we're going to need a more advanced tool. Think of this as your secret inspector gadget for getting a closer look at all the evidence on your canvas. Now, before we use our new gadget, we need to understand a really key concept: top-level code. All this means is any code that isn't tucked away inside a function. And the crucial thing to remember here is that this code only runs once, right when the program first kicks off. It's basically the code that sets the stage for everything else. So here's a situation you're definitely going to run into. When a program uses mouse events, the inspector tool is often hidden by default. But there's a secret trick to bring it out. Just hold down the control key, and bam, the inspector appears, ready to show you the properties of every single object on your canvas. It's a super handy trick for when a print statement just doesn't cut it. All right, detective, time for our final and maybe most challenging case. This one involves a very common culprit in the world of coding errors: mismatched numbers. But don't you worry, we can crack this code with just a little bit of simple math. So here's the deal. We're trying to do something kind of cool. We want to make a circle's opacity change based on the mouse's X position. The problem, well, our canvas is 400 pixels wide, so that X value can go all the way up to 400. But the opacity property, it can only handle values from 0 to 100. If you try to give it a number like, say, 250, the program just throws an error. And this brings us to a classic programming puzzle. We have one range of numbers, 0 to 400, and we need to translate it or map it into another range, 0 to 100. So our program doesn't crash. So how do we make those big numbers fit into the small container? And you know what? The solution is beautifully simple: division. Since our input range of 400 is exactly 4 times larger than our target range of 100, we just have to divide the input value by 4. By setting opacity equals X divided by 4, we scale everything down perfectly. And you can see exactly how this works. When the mouse is way over at position 0, the opacity is 0. When it's right in the middle at 200, the opacity is 50. And when it's all the way at the edge at 400, opacity is a perfect 100. We've cracked the code and we've avoided the error. Simple as that. And just like that, with these cases solved, you've learned the fundamental techniques of a real code detective. You are the debugger. You now have the tools you need to find the clues and solve the mysteries hiding in your own code. So let's do a quick review of your new detective toolkit. You've got the print statement, that's your trusty magnifying glass. You've got the inspector, your secret gadget for a closer look, and you've got basic math, the key to cracking those tricky value errors. These are your go-to tools for pretty much any bug you're going to face. With this new toolkit, you're ready for any bug that comes your way. So the only question left is, what programming mystery are you going to solve first? Happy sleuthing!